Whenever someone asks me what do I do, I have to start with I'm an architect. Then comes the twist. I'm actually a programmer. So what do you actually do? Well, there is a new profession emerging and I don't think we have a definite name for it, but let me explain what do I do and what many others in the world are doing. You are aware of the automation in the production of almost any physical product on the market, from a soup can to a car. Since you make million copies of a single product, it pays off to invest a lot of time and energy into automating the process. In architecture, you're almost always dealing with unique projects. So it makes no sense to spend time in developing the means of automation when you're going to use them only once, right? Well, in architecture you usually automate some parts of the building process, but when it comes to design, structure, drawings, you usually do them manually, from scratch. However, today we are witnessing extremely complex projects emerging all around the world. The forms that we know from industrial design are growing, and the mathematics developed for the car industry is used for building airports nowadays. So the reason why we try to develop automated methods is the need to deal with the complexity. The reason why complexity is evolving in such a rapid way is because we are developing good methods of automation. So this symbiosis proved to be a stable idea, and it's spreading from one architectural office to the next. We had complex architectural projects in history, but in order to build them, we needed an enormous amount of time and working power. Times have changed. We build computers to simulate and calculate zillion times faster than we can, more efficient and more precise. So we just have to instruct them properly and watch them create. So this is what we're trying to do. We are working on those instructions basically. Well, as everything in nature, we humans try to do as much as we can with the least amount of time and energy. So in construction business, we often rely on prefabrication. By using simple elements copied million times, we achieve complexity. We realize that if we make a standard element and a standard connection, we can achieve really stunning and complex structures. But there is a whole level of structural complexity that, for example, nature has, that we just couldn't afford. If the shape of our project is a free form, like in the industrial design, like in nature, a form that has no geometrical regularity, a form that when subdivided in any way consists of unique elements, then we have to forget about old methods of design and production. Some of the projects that I worked on had several hundreds of thousands of unique steel rods, for example. So can you imagine someone drawing them by hand? It just doesn't work. So I had to automate the process of drawing. I had to program it. That is how it starts. Unique elements, thousands of them, cannot just be copied. You have to design a rule behind their generation and give the computer instructions on how to draw them. And you don't stop at the simple lines. You can automatically generate complete 3D geometries of architectural elements. You can automatically make blueprints for each unique element. Imagine drawing something like this for 10,000 unique connections. How about 100,000? Instead, you think, make the rules, write the code and hit enter. The term behind this is parametric design, because by changing a couple of parameters you can control a complicated geometry. But we don't stop there. There is no use in drawing everything automatically if you need to produce every single element by hand. So we automate the production as well. We use CNC machines and robots to do the work for us. But instead of doing one single action for millions of times, like in the car industry, we program them to do different actions. After the CNC machine receives the instructions, it doesn't really care if all the elements are the same or if they're all different. It just works line by line, and those lines are generated automatically. But we don't stop there. With automation of this kind, we know what we want to do, but we don't have the time and energy to do it, so we instruct the computer to generate the geometry and cut and mill instead of us. How about stuff that we don't know? We can use different kinds of simulations to find out what the best possible structure looks like when our intuition or knowledge is not sufficient. Using different kinds of optimization techniques, like genetic algorithms for example, we can let the computer generate thousands and millions of solutions in a simulated process of evolution in order to find the fittest structure or the optimal facade element. How about energy saving? You can easily incorporate sun positions and shadow calculations into the process and optimize your design to fit different criteria at the same time. So our specialty is the combination of static analysis and CAD programs, so we can generate and statically calculate thousands of different structures within a single hour, thus doing something you would probably need several years to do by hand. But we don't stop there. We're developing a special type of artificial intelligence that will let structures evolve to fit a number of criteria. Basically, the reason why it is so difficult to define what we do is that it is a very broad and creative field. People today even have trouble imagining the degree to which processes in architecture can be automated. That is why one of our main tasks is to show people not only what we do, but what we can do. Every project comes with a different set of problems, and that is the most challenging part in this discipline. You always have to come up with new solutions. The other challenging thing is that you have to have knowledge and good foundation in three fields: architecture, structural design, and programming, in order to create efficient and useful methods. Being an expert in one or even two out of these fields will not get you far when it comes to practical problem solving in the building industry. So the important thing to remember is that the possibilities are there and they're not fully used. The first step is to think about programming and integrate it from the very beginning, from stage one in the design process. Nowadays, programming comes at the end only to solve problems emerged during the design. But if we use automated process from the very first until the very last phase, we can achieve much more than we do today. We can be more efficient and we can build much more creative structures than ever before in the human history. And we don't stop there.